Alrighty, welcome to Math Mode. So what we're doing today, this is largely in preparation for your work sample, which is coming up on Monday the 9th, and it will be on systems of equations. Damien, you may want, I know you're in a different algebra version as far as B versus A. We may want to look to see if you need to do one and have you do it since you're here on Mondays anyway. Otherwise, yours is on statistics and it's the January 4th.
Okay.
Alrighty. So, anyway, I'm just putting in another plug. Monday the 9th, systems of equations work sample. So, you guys may not even know what a work sample is right now, or systems of equations. So, what we're doing today is I can solve a system of equations graphically, and I can identify when a system has 1, 0, or an infinite number of solutions. So, even if you're not in this particular module yet, I know a couple of you are pretty close. So, first of all, what is a system of equations? If you were to take a guess, what does that even mean? Wild guess.
A system of equations.
Okay, you can't define something with its.
That's what some dictionaries do.
What?
That's what some dictionaries do.
Yeah.
They just use it without its plural, and that's its definition.
Not very often. Once in a while that does happen. So, what do you think? What does a system usually look like?
Well, it would have to be more than one.
Okay. Yes. So, we have more than one or greater than one equation. What does a solution look like when we're graphing? Seems like that came up.
Solution. Oh, so like the line?
Yeah, so if I draw a line that looks like this, and I draw another line that looks like that, where's their solution?
Where's the answer?
Where's the answer?
The intercept?
Yes, it's the intersection. It's where these two lines meet. That is what we identify as the solution. So where we have two or more equations, and it's where the lines intersect. Where the lines intersect. Okay. So let's take that information, and what I would like you to do is to graph these two equations that I have up on top here. We have y equals 3x minus 7 and y equals negative 2x plus 3. There's a graph on the back of those little charts. How cool is that? It's almost like I planned it.
Okay, y equals 2.
I was drawing.
Where's David? We're missing David today.
I can text him.
Go ahead. Say, where are you? We're doing good stuff. You're missing it.
Wait, what's the, after minus 7, what's the red thing?
Oh, that's a semicolon.
Oh,
That's just to separate.
okay.
So this is one equation, and this is another equation.
Hmm?
Anyone need help getting started graphing? Need help with a pen? Is that one bad?
It's like, kind of, yeah, it's like not working.
Well, then why would you put it back in there?
Yeah.
True.
I'm anti-bad pens. So Keaton, I see you drawing a bunch of dots. Why? How?
So I can connect them.
So you can connect them. How do you know that they're in their right home?
Because you follow the rise of
Follow the rise of the. So where are you starting? What's your starting point?
There's an actual term for it, but a -7 and positive.
Okay, so let's just look at this first equation here. So you started with -7. What is the -7? What does that represent?
Wait, is this like the y equals mx plus b?
Yes.
Oh, okay.
Yes.
So it's the y-intercept?
Yes. Plus b. So any number that is in the b location is the y-intercept. Okay, so if I draw a t-chart, if I have recognized that y is -7, what is the value of x?
0.
It's 0, yes. So that tells us, for this first point here, when x is 0, the first dot is going to be here on the y-intercept.
Oh, okay.
So when x is 0, y is -7.
So like the ordered pair for that would be like 0, 7.
Yes, yes. 0 minus 7.
Or negative.
Uh-huh, you got it. Thank you. I love it. We are going to get rid of these pens.
So if x equals 2, what would it change? Would that just change the rise over the run, or would that change also the y-intercept?
Neither.
Neither?
So when you said when x is 2,
No, I meant like if x the starting, would it ever give us what x was? Say x was 2 in that equation.
okay, so let's plug in x is 2. So y is equal to 3 times 2 minus 7. Can you solve for y in this particular example? Yeah, yeah. So y is equal to 6 minus 7, or y is equal to -1.
So now what does that do? Now that we have 2 -1, is that
Can we graph this? This is an ordered pair.
So that's okay.
Yeah. Yeah, if I
He just
were,
woke up, is what he said.
Oh my gosh.
that's how we write it in ordered pair format. So we can find x is equal to 2, and we can drop down 1, right?
Mhm.
Bada bing, bada boom. Now, can I connect those dots?
Sure.
Sure. I'm just going to stick with orange.
I must be hard to do on a dry erase board.
All right. Can you, or will you, well, don't you have the slope?
Oh wait, yeah, you already do. Just kidding. Never mind.
Yeah, you have the slope.
Yeah.
It's 3. 3 over what?
Oh.
3 over what? Yeah.
Yeah.
So I could even start from my intercept, and I can go up 3, 1, 2, 3, and I can go over 1, and I can find the next point, and I can drive. So that is another way, Annie. You know, after graphing the y-intercept, we can use slope. Hello, sign in, Miss Lori. And if you would grab a dry erase board, a marker or 2, some of the markers are a little iffy, and an eraser. All right. So how about this equation over here? How would you start, Damien?
I'm starting
Right, oh, new pen, that's good. Hey, you're even making this
This purple
basket.
is decent if you want it. Hey, this one works. I really don't have you stop working for you now. So.
So while we're waiting, make sure that you've got your lines drawn.
I like to mix colors.
Draw a line. So Lori, what we're doing is solving for systems of equations using a graph, which you're in a slightly different algebra class, but you use this information in yours, so it'll help you with parabolas. Thank you. Look at this. I'm gonna have to get Rachel to place the order, aren't I? Hello, Olivia.
Hi.
So if you would write on that, and then there's a dry erase board there with lovely messages. You would grab a marker and an eraser. We're doing some graphing. Okay, Damien, how would you start graphing this second equation over here?
Can we get rid of our first equation?
Hmm?
Can we get rid of our first equation?
No, leave it there. Because we are looking for this. We're looking for where the lines intersect.
Oh, okay, cool.
All right?
Yeah.
So I don't want you to erase your line. I want you to keep it.
Where's the whiteboards?
There's one right next to Keaton there that has like poetry or
Oh.
something on it. Positive affirmations. All right. So where would you start? What's the number?
2x.
Okay. What are you going to do with the 2x?
Negative 2x. So you would take it and
Yeah, I think I would
so you start with positive 3.
And what is x when y is positive 3?
0. Oh, sorry.
0.
0. Good job. So I always like to set up my xy table. So when x is 0, y is 3. I plug that in like that. So I'm going to use green. When x is 0, y is positive 3. Okay. So now we need to find another point. Annie, what do you think?
you take 2x, right?
Yeah, it's negative 2x.
Or negative 2x, and how would you put that on the table to
What are you trying to do?
find the next point?
Okay, so what comes after 0?
1.
1. Yeah, we can use the next point.
Okay.
So when x is 1, what is y?
4.
So what we have right now is negative 2 times 1 plus 3. Negative 2 plus 3 is what?
Oh, 5. Okay. Oh, geez, no, it's not 5.
Uno.
Actually,
Uno.
1.
It's 1. So what I'm doing is I'm substituting a value for x to figure out what y is. Keaton,
Can't you just go down 2 over 1, down 2 over 1? Down
You
2
can.
over 1?
You can, absolutely. So where's my, there it is. All right, so when I have x is 1, y is 1, does that follow this rule of slope? Which right now our slope is negative 2, and there's the invisible 1. So if I go down 2 over 1, voila, Look at that, I found the point. All right, so now, what should I do, Colton? Yeah, draw a line. And I'm going to be just as precise as I can be. Okay, so now we have an intersection. So based on your graph, which should be more accurate than mine, since I eyeballed my spaces. So go ahead and graph 0, 3, or plot it, and then 1, 1. What we're trying to find is the solution to these different equations. Where is the solution? So I heard 2, -1. I'd like to hear another solution.
Mine is like 2, 0.
2, 0?
Yeah.
Okay.
2 -1.
So we have another 2, -1.
2, -1.
We have another 2, -1. Lori, Olivia. Okay. So let's test it. We can test this mathematically. So if I put in 2 in this equation, I should come up with -1. Does that work? -2 times 2 plus 3, -4 plus 3. It does. So the solution, I'm just going to make my circle a little bigger. The solution, when you're answering this question, the solution to this particular problem is 2, -1. The solution. That's where those 2 points, 2 lines intersect. All right?
Is there a way you can find that without graphing it at all?
Yeah.
Or is that just how you did that? When you replaced it with the 2 and
Yes, all of the above. So I didn't need to graph it, right? I could have started with my T-chart and filled in every number, let's say 0 through 5 in both T-charts, and I could have started to look for a solution that way. Okay, so if I had, let's say this was already filled out, I want you to be able to look at your T-chart and say, oh, that's where the solution is. It's where the numbers match. All right. Now, I'm going to erase most of this. Well, before I do, I want you to work on another problem. So our local high school is having a musical, and they're going to be selling tickets. Now, in their auditorium, there's a total of 400 seats. Now, students are charged $3.50 for every ticket, and adults are charged $6.50. Now, the drama department, they want to break even to cover all of their expenses. They have to bring in $1,800 to cover expenses. What I want you to do is to make a graph with 2 different equations to find the combination of both student and adult tickets that have to be sold in order to cover expenses of $1,800.
33 of each.
I know you are kidding. So we're trying to find out where that happy spot is. Where we have the right combination of adult tickets and the right combination of student tickets to cover our expenses. Where's that sweet spot? And if you have questions about how to start, throw them out there. Let's help each other. Any questions? Feel free to help each other.
Cheating.
What are you doing? Guess and check doesn't work.
This isn't guess and
No,
check.
that
You-
is guess and check.
You can figure it out by just using the numbers.
What numbers? Where are you starting, Keaton?
Well, you have a starting point of 350 and adult 650.
Okay, so we've got ticket prices. So we have students, it's equal to 350. We have adults that are equal to 650. Okay. Are you just going to throw numbers out there until they add up to something?
So, do they each have to earn 1,800, or do they both have to add? I'm guessing
They both have to add up. So imagine that you're going to, what movie theater do you go to when you go see a movie?
one by the in the college direction.
Regal,
Yeah.
right? So Regal, there's only so much space in that auditorium to watch that movie. So Regal has to earn $1,800 to cover expenses. What combination of student tickets and adult tickets do they need to sell in order to hit $1,800? Knowing there's only 400 seats.
So that's your starting point or something.
Well, we know that we're trying to find a solution, right, to our system of equations. So there's two equations that we need to write to get started.
Would both of the prices be in each of the no, that doesn't make sense. Like, would one equation have the student price and the other one would have the adult price?
No.
So is it 1,800 equals 350 plus 400? Is that your equation for the first one?
You're headed that. You're getting closer. So we have seats, right? So what equation, you're going to have adult seats and kid seats. And what do they have to add up to?
1,800.
Okay, so let's assign a variable to students. X. Okay, so students are going to be X. So that means that the adults are going to be Y. Now when we sell our tickets, so these represent the number of tickets. What are they going to add up to? Okay, now remember, these are seats. These are seats.
Are we doing 200 and 200 for seats, or is it a difference? Because of, never mind, okay, that makes sense.
It's some combination. They probably need to sell more adult tickets than student tickets. But you were onto something. You were onto one of the equations. So if we had 200 student tickets, what would we charge?
350 times 200.
Yeah, 350 times 200 plus,
50 times 200?
yeah, 650 times 200. I'm going to move this over here. So if we have 350 times 200 plus 650 plus another 200, that has to equal 1,800. Is that where you were going? All right. So if I were to substitute some variables, how will you rewrite this?
Substitute variable.
Yes,
Uh,
here and here.
well, you would change the 200 to whatever you.
350x
Oh, okay, so
plus
yeah.
650 y is equal to 1,800.
Oh, right, the seats are
Okay. So this is one equation.
Oh, okay. You didn't see that. That's
Can we solve for y? Okay.
what happened?
So Olivia, how would you solve for y? What's the first thing you would do? Hmm?
Plug it on the graph.
Alrighty. So give me more. Tell me what you're thinking.
650. You have to go up.
Right, but we do not have this in slope-intercept form yet. So, Colton, what's slope-intercept form?
R equals MX plus B.
Excellent. Okay, y equals mx plus b. Can we change this around so it's in this format?
Can't you just
Can't you just what?
switch 650y and 350x? No,
Would you as
we can, but it wouldn't work.
So if we're solving for y, how do we solve for any variable?
I see.
You isolate it.
So you minus 350x?
Yes. Yeah, that's exactly what we do. We subtract 350x from both sides. So then I'm left with 650y is equal to negative 350x plus 1,800. Everybody with me so far? Give me a thumbs up if you're with me. I got one thumbs up. Alrighty. Now, how do I solve for y?
We can get rid of 650.
How do I get rid of it?
We got it.
Yeah. So let's divide by 650. Alrighty. So, I need you guys to help me with the math. What's
It's crazy. negative 350x minus 650 is negative 53846153846.
Okay, so negative 0.538 x, and what is 1800 divided by 650?
276.923.
Do we have confirmation? Yeah. What did you say again?
276.923.
Okay. 276.92. All right. Can we graph this? I might need to change the scale on my.
Knock, knock. Just to let you know, open your window right now.
Uh-oh.
It's snowing.
It's snowing.
It is?
Yeah.
Oh, yay.
Yeah.
Oh,
Yeah,
look at
that's
that.
Yeah.
All right, we better figure out systems.
Okay,
So we can all go
Sorry for
home and have hot
interrupting.
cocoa.
Well, this is fun.
No problem, Edward.
I gotta walk home like 2 miles too.
Oh,
I'm
you'll be
kidding.
fun. Oh, you'll be just like your grandparents.
Huh.
Walking 2 miles through the
I used to walk
snow.
to school and I wore shorts every day, so I just wear sweatpants as I walk to school.
Oh, you're crazy.
That's so cool.
That is cool. Those are pretty flakes.
Thank
Oh
you.
my.
So that
I might need to go home.
my mom or my dad said it's gonna snow on Monday. I was like, no, they said it's gonna snow on
Have I
Wednesday.
been here
It's
for
not
long
snowing on
enough?
Monday.
Have I been here for long enough? I haven't gone home.
Have you? No. It's not even sticking.
Is David just not gonna come because he didn't wake up?
I have no idea. You can send him a text. Alrighty, so can we graph this? Damien, what is the y-intercept? I'm going to call this 500.
Y-intercepts.
Say it again. When x is 0, what is y? If you can't read the number, that's totally understandable.
It would be Y.
So think of the t-charts. When x is 0, what is y?
Oh, with X is 0.
276.92.
How come? How come?
Because
Yeah.
because it's the y-intercept, and we just answered x, and we've been doing the same thing the entire time.
It's because, so I'm trying to figure out where my ordered pairs are. When I substitute 0 for x, y is equal to negative 538 times 0 plus 276. Ooh. What's anything times 0? 0. So I can look at this first number, the intercept. Okay, if that's not a working one, what we're doing, Olivia, is we're chucking them.
Okay.
Yeah, if it's a bad one, let's.
Throw it from here.
Woo! You guys, we ought to have a team of something.
Yeah.
276.92.
Basically, the anything with x is your slope, and this number by itself is your starting point.
Yes, this is always your M. Good. This is your slope right here.
You go down 0.538.
Yes, ma'am.
Can I go touch the snow?
Oh my gosh. How about if we finish this, then you can touch the snow.
Yes.
What happens if you open that emergency exit? That's so called emergency exit. Is that even legitimate?
Okay, let's finish this one, then you can touch the snow.
Oh, yeah.
Alrighty, so one idea, because this is kind of funky. What's negative 0.538 over 1? Well, that's going to be a little difficult to graph. What if I put in a 0 for y and find the x-intercept? I put in a 0 for y. So Colton, help me rewrite the formula. How do I substituted 0 for y? What do I write?
0 equals negative 0.538x
Mm-hmm.
plus 276.91. Is that one?
Yes. Or 92, I know. Look, I just squish everything. That's what I do. Okay. So let's solve for x. And then we'll touch snow. I know a fading audience when I see it. All right, how do I solve for x?
Subtract 276.92.
Yes. So I'm going to subtract 276.92 is equal to negative 538x or 0.538x. What is x equal to?
Well, wait. You have to divide x by 538.
Yes, it's negative 0.538.
Okay.
So everybody get your calculators out.
David tried to correct my text, and then by doing so, he made fun of my your, and then he messed up his own your.
Sounds like something I would do.
Negative 514.72.
Okay. Negative?
Negative and a negative and a positive.
Positive. What my calculator says it's not. Oh, maybe because I forgot to put a negative on something.
Oh, don't forget your negatives. That'll mess you up every time.
So 514.72.
514.72 is equal to x. So then I can, so if I have my xy table, and 514.72. So using my intercepts, I can graph this now. And each one of these is 500. So when x is 0, y is 276, which is about here. And when x is 514.74, y is going to be 0. That's about there. And I can draw my line. Does everyone see what I did? And why? I am substituting values in for x and y. Or substituting a value for x so I figure out what y is. I substituted a number in for y to find out what x is. You can do that. Okay, so we have one graph, one line, but we have a system of equations. What's the other equation? So this one dealt with the cost.
The goal.
How about seats? Are we constrained by the seats?
Yeah.
Yeah. So, if I have student tickets and I have adult tickets, what will they add up to? 400. Can I graph this? Put it into slope-intercept form and graph it? Yeah. What do I have? What's my formula? Is what?
MX plus B equals MX plus B?
Yes. So put it into that format.
Oh, y equals x.
Minus x. Because I'm subtracting it from this side.
Plus 400.
Okay. So, at least I see smiles. I like that. All right, so Damien, what's my y-intercept? When x is 0. Yes. Yeah, absolutely. All right, so it's a positive 400. It's going to be a, whoops, right there. And why don't I substitute a 0 in for my y? What will x be?
One. I just said it. I have no clue.
Yeah, I think it would be 1 because that's what we did on the other day.
Okay, let's erase this. So if I have 0 is equal to negative x plus 400, right? So I'm going to subtract 400. Minus 400 is equal to negative 1x. I'm going to subtract this by a negative 1x, or divide, I'm sorry, by negative 1. I end up with positive. So in this case, they're totally flip-flop. That does not normally happen. Does everyone see what I did? How I made that positive?
Or did you take it from there?
Take what?
Oh, okay, so you just used the original. Okay, never mind. Makes sense.
Okay.
I didn't see that whole equation until just now.
Oh, okay. There you go. All right. So when x is 400, which is right over here, y is going to be 0. And then I can connect the dots, and we have a solution here. So in order for the drama department to break even and cover their costs, they have to sell 200. This is not to scale, so your graph should be a lot more accurate. But they would need to sell 266 adult tickets and 134 student.
We're just gonna turn down like 2 parents' kids or something.
Well, maybe.
How many adults go to a high school musical thing?
Many.
Many?
Yes. Yeah. Damien, have you ever been in a play? No. Olivia? Lori? Annie?
Not a high school one, but I know
Well,
that
every-
if you at least have like 100 people in a cast, that's like 200 parents plus other relatives that are adults.
Yeah. So Colton, when Peyton is performing, are there more adults or more kids? Yeah. Yeah, you're getting drugged along because it's your sister, right? Okay. Alrighty. Questions? Oh my gosh, we have to go touch snow. Okay. We'll go touch snow. Stop.